So this lesson is on the concept of images. Images are what you see when you look into a mirror or you look through a lens at another object. We saw some images yesterday looking into concave mirrors as well as the plane mirrors. So we want to go into a little bit more detail of what one can expect in general. So as we mentioned before, when you look into a concave mirror or any mirror, you didn't see an actual object, you saw the image of that object. Okay. So let's talk about that concept a little bit more. So the reason this happens is if this arrow represents an object, we have light coming from it in all directions. It hits this concave mirror and it's going to reflect. So you can see we've drawn a little normal here. So if I come off and we come in at some incident angle there, we have to reflect at the same angle. So I'm going to go and draw a ray that's supposed to be straight that more or less goes through what I have this reference point as a dot. And if I look at this incoming ray and I draw a normal that's a little less obvious what that normal is, then it's going to come out more or less like this. And if I draw a normal for this one, which is almost directly on, it's going to reflect back like that. And so we see all three of these rays, upon reflecting, converge at a common point, and that common point is where the image from that arrowhead will form. If we do the same thing for the base of the arrow, and I'm not going to draw the rays here, we will see that the reflected rays all converge right about here. So we can draw in an arrow that would be upside down in this case, but that's where the image is. Okay, so that partially explains how the pig worked, or even the car. So when you have light coming in from in front of a concave mirror in such a way that the light rays converge, focus, it could be another word you use here, okay, and in this case it converges at a point in front of the mirror. And we'll go into much greater detail on this later on. So this type of image, because light really comes to a focus there, is aptly called a real image. Okay, because light is actually coming to a focus. The properties of this image, in other words, how big is it compared to the object, where is it, what's its orientation, what type, depends on two important parameters, which again we'll go into greater detail. That depends on the curvature of the mirror, how concave it is, and as we'll see, which is a little less obvious, the location of the object relative to the mirror. So we'll learn that as we move this object closer or further away, the image properties will change. Now, another important aspect of real images is that real images can be projected, okay, onto a screen or elsewhere, films. Okay, so they make them very, very important in optics. Now, the other mirror we looked at was the plane mirror, the more common mirror. And again, when you look into a mirror, you might say you're seeing a reflection of yourself, but again, the technical term is an image. Okay, the question is, how does this image contrast with the image we saw in the concave mirror? And where is it located? Well, we did the activity in class, so just to reiterate, if I've got, again, an object in front of the mirror, I've got three random rays coming off. If I draw normals, then I see that this ray reflects off like that. This ray is coming straight in, so it will reflect straight back. And this one is coming in down, so it's going to reflect backwards as well as down. Okay, so if your eye is out in front of the mirror looking at these three reflected rays, in other words, you're looking in the mirror, which means you're picking up the reflected rays from the object, you will see that none of these converge out front, but your eye will think that the rays all originate from a common point. And so at that point is where the eye will see the image of the arrowhead, And if we do the same thing for the bottom of the arrowhead, your eye will see an image back here. Okay, now I haven't drawn this very well to scale, but the rough idea here is that the image is located behind the mirror. Okay, so this type of image is called a virtual image. Okay, because this reflected light never actually converges, but rather appears to focus or originate behind the mirror. Okay, and an important property of virtual images, in contrast to real images, they cannot be projected. Okay, so a neat little example we can try to help you understand how the wall reflection is if I place an object, let's say the letter B, in front of this mirror here, we want to know two things. Where would you have to be in order to see the B, and what would the B look like in the mirror? So I'm going to pause for a few seconds and you try to work this out before you press play. Alright, so hopefully you've taken a few seconds to actually try this yourself. So we want to understand where you would have to be to see this B, and what would the B look like in a mirror. So the first thing you want to notice is that the B is not directly in front of the mirror, but that's okay, it doesn't have to be. We can pretend the mirror extends out to infinity in all directions. Okay, so light is going to come from different parts of the B. It's going to reflect in this general direction. Okay, so if it hits further down, it will go down like this. So in order to see it, your eye can't be up here because there's no reflected light that's going to come back to you. Instead, you have to be in this general vicinity. So your eye picks up reflected rays that seem to be coming not from up here, but rather seem to be coming down at it from around here. Now if we use the ideas from above and what we learned in the lab, then the image of the B is going to be behind the mirror. Now where behind the mirror? Well, it's not restricted to the boundaries of the mirror. Again, we can extend the mirror line out as far as we want. In theory, an object could be way off here and you could still see it if the angle is right. Anyway, we want to be directly behind the mirror line, and we also learned that it's equidistant. In other words, this line part, if it's a certain distance in front of the mirror, will be the same distance apart. So if I approximate this, go back the same distance, then the line part of the B should be right here. The circle part is closer to the mirror, so in this one it will be closer. Alright, now you can clearly tell mine is a little offset. It should be a little bit higher. This seems to be a little bit bigger. So if I try to do that again, okay, maybe I can do a slightly better job. Okay, so here is the line part, here is the circle part. Alright, that's a little bit more respectable. Each part should be exactly behind the other one. So this is what the B would look like. Same size. In this case it seems to be inverted. Well, it's not technically inverted, but depends on how you look at it. And that's how you solve a problem like this. So this concludes the introduction to images. We will be doing more formal analysis with ray diagrams and even equations for the various mirrors to understand all the possibilities one can get when you look in a mirror.